Hi, everyone. Calista is always a really tough act to follow, so is John. So I'm going to do my best. First of all, I truly want to thank each and every one of you for coming to RISC-V Summit North America. It's definitely been a labor of love for a lot of folks, and it's just so exciting to see you here. And now I want to welcome you to Launchpad. As Calista articulated, this is a RISC-V first. We're having a go. What is Launchpad? Well, one of our goals with the North America Summit this year is really to show RISC-V is here. Make it real for all of you like we know it is. You've heard some really great announcements today. You know, on this stage, you heard Ventana talk about its new solution. You heard Microchip talk about its new solution. You just heard John talk about what Synopsys is launching. So you've heard some really great announcements. But we have so many other members that we knew were having big announcements in the time frame. We really wanted to figure out how do we give them time to be able to communicate what they've done and what's so exciting about it. So I know in general, people really want a technical conference. I know it's like, ooh, a marketing pitch. That's not what you really want to hear. I recognize that. But my thought was, with this, is if we made them super short, if we gave folks the stage and we were like, yes, these are overt marketing pitches, but you only have 3 minutes and you better bring the best of yourselves here. So that's what we're doing. We brought together 8 companies that have had recent announcements or some that are coming, and we're giving them 3 minutes to put their best foot forward and tell you why their product, their RISC-V-based product or solution is really super exciting. So with that, we are using this session to launch their product, so hence Launchpad. Yes, I know. So with that, first and foremost, we're going to start with Andy's technology. Our speaker is going to be Marvin Chao. Marvin is the Director of Solution Architect. What he is going to be talking about is the D25F-SE. It sounds like it should be a Star Wars droid. The D25F-SE is like the superhero of RISC-V CPUs, equipped with the mighty prowess of packed SIMD DSP extensions ready to tackle voice, audio, and image tasks while shielding the world from systematic failures and unexpected hardware mishaps with its reliable safety cape. With that, please join me in welcoming Marvin to the stage. Thanks, Marvin.
Thank you, Tiffany, for the kind introduction. So today I want to share the latest RISC-V functional safety solution to everybody, the D25FSE. So I forgot the clip. Yeah, I was told to share something fun in front of everybody before the first drink tonight. So I'll first start the introduction with the potential application for the Andy's D25FSE. This core is really designed for a wide variety of different SOP applications, from inside your car to outside your car. For example, inside the cabin, you have the in-car monitoring system. The touch and display is essential for the infotainment system in the modern-day cars. And the in-car storage is also essential for the digital cockpit nowadays. And outside the vehicle, that you can also see various different of the ADAS features. For example, the automatic light beam control, the blind spot monitoring, the adaptive cruise control. And all the cars today ship with a variety of different CMOS sensors. And this is also one of the critical applications that we meant to support with the D25FSE. Now I want to share some of the architectural high level about this core. The D25FSE is highly effective. The core is a 5-stage in-order single-issue processor. It's a 32-bit RISC-V core. The core comes with the additional instruction set, the GCBP. For the P extension, this is a RISC-V packed SIMD. This opens up a lot of possibility to accelerate your application on the automotive controller on this core. And also, for the bit manipulation instruction, and this opens up the potential application for things like cryptography. And when it comes to the memory subsystems, that you can configure this core with what your application needs. For example, you can configure with various different levels of cache as well as local memory for both your instruction as well as the data. And when it comes to the bus interface connect, the D25F SE supports all the common bus interface, including the AXI as well as the HB. If you choose to configure the core with the local memory, the core will also provide you a direct access to the local memory, so you can share the content of this memory with the rest of the system. And when it comes to the functional safety, this core will provide a various different safety mechanism. For example, the core trap status bus interface will allow the system to query and keep track of the status of this core. And all the memory on the D25FSE is protected through ECC and the standard RISC-V physical memory protection. For the stack safe, this is an ND-specific feature to provide you additional memory protection for the stack overflow. The D25FSE is scheduled to be fully certified around the Q4 2023. So we're at the last phase of the certification process, and you will be ready before the end of the year. So in this last slide, I want to show some of the benefit for having the DSP extension on the D25FSE. That what you can see here is this is why D25FSE is effective. If you want to implement various different DSP algorithms on this core, you can expect the acceleration and benefit from 30% to 4 times performance improvement. And overall, we expect this core to deliver about 3 times performance improvement compared to the core without the DSP extension. And this provides many of the functional safety core beyond what we can cover in the 3 minutes. So if you want to know more details, please stop by our booth at the D4 for additional information. And thank you very much for the time.
Perfect. Thanks, Marvin. How many of you have visited the Developer Zone today? Hopefully you've gotten a chance to go to the expo area, yes, hopefully, and see the Developer Zone. Well, if you were there, you probably did get to see some contributions from BeagleBoard. And next up, we have Jason Kridner from the BeagleBoard.org Foundation. As a 28-year veteran of Texas Instruments, Jason developed experience in the design, manufacturing, testing, applications, and marketing of integrated circuits used in embedded systems. Jason's vision is to drive access to technology without barriers, and he is here to tell you about the Beagle 5 Fire and the Beagle 5 Ahead. Please welcome Jason.
Test. Okay. Got the clicker, and where can I see? Press the button. All right. So we really want to bring RISC-V home to you, right? So we're kind of that last step, right, where you actually want to get your hands on something. I think it's something that might seem fairly simple part of the whole process, but I think it takes a nonprofit like us to have the longevity, the patience, and the tenacity to make things really successful, right? So I think we made a big difference in bringing ARM to a lot of new application space. I think innovation kind of happens at home, right? Innovation happens where you see the problems of daily life and you think about how to solve them. So we try to give the world tools that they can, learn to tackle the problems that they encounter, right? So we stay with the platform for a long time. We provide support. If you need to talk to me because you're not getting a good answer out of the community, go to the website, visit the About page. There's a way to schedule a meeting with me because it ends here, and I guarantee that I don't know the best answer, but there's people in the community that do, and we really want to make sure that people can actually succeed, right? So we're around there for the patience and tenacity to make that happen. So first, we have Beagle 5 Ahead. This is a mobile processor, but it's extremely powerful. C910 quad core, 2 gigahertz, 3 three out of order execution stuff. It's really cool. It's got neural processors and graphics and H.264 and 265. It's got camera inputs, and I cannot possibly go through all the things that you might be able to do with this, but you can get one yourself for about $150 in worldwide distribution, right? So, and you can get lots of them, right? There's a ready availability, and we're going to try to make sure that they're around for a good long time. So that's Beagle 5 ahead. And just announced is the Beagle 5 Fire. This is using a microchip polar fire. It's got a quad-core U54 MC and an FPGA fabric, right? So the first Beagle to bring you FPGA capabilities so that you can, if you want to make other cores and test those out, you can do that. We make it where you can reprogram the FPGA fabric from the Linux environment, right? You plug this in, it gets you a network interface over a USB cable where you can log into the board and work with it directly within the Linux Ubuntu system there. And you can submit jobs to our GitLab to rebuild the gateware for you and run the script and run those on your board, right? So it's really great for things that are really low latency, things where you want to build industrial applications, right? So I think we're covering a lot of different application space for RISC-V. So check us out, beagleboard.org. Thanks.
Thanks, Jason. And thank you to BeagleBoard because they've actually donated a few boards that will be given away at the show. You can stop by the RISC-V counter in the expo area to find out what you have to do to potentially win one of those boards. Okay, next up we have Codasip. Mike Eftimakis, he's VP of Strategy and Ecosystem. Mike has one slide. Mike is known within Codasip as Mr. Custom Compute, and he is here to find his broader audience. Mike will tell us what is custom compute, how it relates to Codasip's new 700 processor family, and why he's so excited about it. So please welcome Mike.
So I have to click to get my slide. Here is it. So yes, I'm Mr. Custom Compute, and I'm obsessed about custom compute. And well, this is because I'm in charge of strategy at Codasip, and this is our differentiator. RISC-V has been designed to be different because one key feature is the ability of choosing the instruction you want for your application. So why would a RISC-V company try to mimic legacy IP players? From a strategic point of view, this is a recipe for failure. So that's why from the outset, Codasip has decided to be different and to make custom compute a reality. Custom compute, the ability of tuning, customizing the processor to your application, brings great benefits. Here I'm talking about efficiency improvements of 1,000% or even 10,000%. That's what we see with our customers. Unfortunately, custom compute is extremely difficult to do by hand. And that's why Codasip has invested in 3 different elements. One, the tools that help automate this process. Secondly, the methodology that help building customized processor from a high-level language, which we call Codo. And 3, we have a range of IP cores that are ready to be customized and that our customers use as starting point for their own applications. And that's why we are the leader of custom compute, and that's also why you shouldn't waste time hacking RTL by hand or trying to modify a processor that hasn't been designed for modification. So that's what we do. And basically, the announcement that we made recently about the 700 family is to announce a range of processors that are designed especially for customizability and flexibility. And for example, the new processor, the A730 that we have announced, is a core that enables an infinity of variations. So that's a great example of how you can use the power of RISC-V in your application. And one great example of customization is that we have designed the first Cherry-enabled processor in the industry. Cherry is a security technology that has been developed by University of Cambridge and other companies for 13 years. And it brings the benefit of, well, preventing 70% at least of existing cyber attacks. So 70% of the cyber attacks that we see now can be prevented with this technology. So that's a big revolution in security, and that's what we bring with this new processor. So, well, just come and see it running on our booth, or, well, come to the keynotes tomorrow to hear our CEO who will talk about this technology and everything we do. And thank you very much for your attention.
All right, thank you, Mike. Next up, we have deep computing. Yuning Liang, he's the founder and CEO of Deep Computing, which makes RISC-V-based innovative products. From the first RISC-V laptop to toy cars you might have seen in the demo area, to the indoor airship you probably saw, to the pad you're about to see. Today, Yuning will demonstrate making phone calls through this pad for the first time. Please join me in welcoming Yuning to the stage.
I'm about to make a scene, double up that sunscreen.
Thank you, Tiffany. Would you mind stay for a second, please? Hi, everybody. It's an honor to be here. And how's today's conference? It's great, isn't it? It can be greater if we have more premium products powered by RISC-V SoCs. So that's what Deep Computing supposed to do and intended to do. We make very premium products, personal computing, night laptop, workstation, and even server racks in the future. And also, we make some of the fun products, some consumer electronics, like speaker, camera, and more. And today, we're going to show you a surprise and on the RISC-V milestones. And can you give me a second?
Hello.
Hello.
Hi, Tiffany. Thank
Hi,
you
Yuning.
for so much for organizing such a great event. And let's make RISC-V greater again and greater. Thank you so much. And yeah, this is the RISC-V pad we make, and with the LTE capabilities that people can make phone calls, can try to make any LTE connection and data and calls. Thank you very much, and see you guys again. Cheers.
Thank you, Yuning. Thank you. Thank you.
Thank you.
Thank you. Okay. It was actually the second phone call because he did practice. It wasn't really a surprise. We tried to pull that off. I probably need to take acting lessons, but it was an attempt, and that was why I'm wearing the jacket so I could have the phone in the pocket. Okay, we are halfway through. Try to get everybody a little more rapid fire. I appreciate your time and patience. Next up, we have Espasa. Our speaker is Craig Cochran. I've known Craig for more years than he and I probably want to talk about. He is Vice President of Marketing and Business Development. And if you haven't heard enough about generative AI lately, here's Craig to tell you about Espas's new RISC-V-based generative AI appliance. So please welcome Craig to the stage.
Thank you, Tiffany. Thanks, everyone. So Esperanto Technologies is one of the original members of RISC-V International, and to that end, I'd like to start with a plug for RISC-V. If you were lucky enough to get to Europe, to Barcelona, to see the first RISC-V Europe event a few months ago, you would have heard a great talk by our founder, Dave Ditzel, who was telling you about the merger of HPC and ML processing. Now, while HPC and ML have different needs for data types, we're seeing that they have a lot of commonality in terms of the needs for the future, in terms of bandwidth, in terms of throughput. And we feel strongly that RISC-V is on path to be the best foundation for the merger of these two things, and that is the direction our company is taking. And we have evidence for this because most customers that come to us wanting to run AI workloads are also asking us, can I run an HPC workload on the same chip right next to it? So just wanted to make that point. So if you haven't seen our chip, it's called ETSoC1. It is, we call it a RISC-V supercomputer on a chip. It has over 1,064-bit RISC-V CPUs on the chip, each with a vector tensor core attached to it. This is our compute fabric for running AI workloads and HPC workloads. And while that sounds like a lot of compute power, and it is, it's very energy efficient. The compute fabric runs at 400 millivolts, so very low power. You can see here a power plot that we took, and that blue squiggly line shows the SoC running at about 13.5 to 16 watts for 3 different typical ML recommendation benchmarks. The system that we put this in is shown here. This system is a standard 2U high data center server that can hold 16 of our cards. So that's over 16,000 RISC-V cores running in one system, and that's being used today for machine learning and HPC workloads. Now, this picture you see on the left is or on the right rather, is a picture of a rack that is in our office, and that's got 8 of those systems. Each of those systems has 8 cards. So 10 of the systems with 8 cards. So what you're looking at is over 80,000 RISC-V cores hard at work in one rack. And we're able to make this rack a lot more dense as well. And, but what I'm really here to talk about today, though, is our generative AI solution, which we announced recently. So our observation is that generative AI is sort of breaking down along 2 lines. There's a horizontal application based on very general purpose generative AI solutions like ChatGPT, GPT-4, et cetera, where they're trained on massive amounts of data but aren't quite as fine-tuned. Then there are vertical applications, and these are based on what you would call foundation models. They tend to be a little bit smaller, and they tend to be trained on much higher quality data sets. And this makes it perfect for our application. So what we've developed is a generative AI appliance, which is the server you're looking at, along with a generative AI software stack. There is the complete application software. All the models are on there. You can see a few of the example models here that we run. And just to summarize with some highlights, we're able to run all the latest LLMs. Our data science team is constantly porting the latest ones that come out every few weeks, and we provide this as a complete solution. Why do you want this? It's in your data center. It's private. You can typically fine-tune it within a day on your own data set and get a lot better energy efficiency out of this than you would with some other solution. So, thank you.
All right. 5 down, 3 to go. I know we said 3 minutes. I will work on the time. Try to speed things up. I do appreciate, as always, I seem to be standing between the RISC-V community and drinks. So it's not the enviable position, but so far, everybody liking it? Interesting, different? Yay? Thank you. Thank you. Whoever did that, I will get you a drink later. Thank you so much. So next up, we have semi-dynamics. If you're looking for a tensor unit IP for your next project, I would like to introduce you to Roger Espasa. He is semi-dynamics founder and CEO, and he's here to tell you about their new tensor unit to run your most demanding AI workloads. So please welcome Roger.
Okay, lots of people. Thank you very much. So they told me they didn't tell me it was in marketing, so I only have a block diagram with technical stuff. So sorry about that. So what have we announced this morning? If you came to the talk, and if not, I'll give you a rundown now. Not only we had a really good out-of-order core with this gazillion technology that allows us to fetch a lot of data in front of large memory latencies. So that was our baseline core. And not only we had the out-of-order vector unit, of course, we think it's the best one in the RISC-V market. But what today we announce is a tensor unit connected directly to the vector unit. And this gives you two very interesting advantages. First, the tensor unit storage for holding the data, the A matrix, sorry, everyone knows what a tensor unit does, right? It multiplies matrices A times B and adds to a C matrix and produces a C matrix, just in case. So the tensor unit input data is held in the vector registers. And we added a new custom instruction called matrix multiply, surprise, that takes the input from those registers, multiplies matrix A times matrix B, adds it to matrix C, does all of that inside the tensor unit, and puts the result back into the vector registers. To complement that, we added two instructions, a vector load and a vector store. There's more details coming tomorrow at the demo theater 3:30, I believe, so come over if you want to know the details. So we added two instructions, and the combination of all of these is really interesting because it's immediately Linux ready. As you know, Linux today understands the vector extension from RISC-V, and Linux can context switch processes that are using a vector unit. Now, this tensor unit is just using the vector state, so this allows you to actually use this, and no changes to Linux, you get a working system with vectors and tensor. And those of you that are into AI will know that the AI models that everyone's running these days have two basic components, right? Matrix multiply, fundamental, very, very heavy compute, followed by what's called an activation function, which can be ReLU, leaky ReLU, sigmoid, you name it, right? So the good thing about having the tensor unit really connected to the tensor to the vector unit is that you run the matrix multiply on the tensor unit, the results end up in the vector registers, and immediately you use the vector unit to do that activation function on the results you computed. This is way better than the alternatives based on ugly DMAs hanging off an AXI bus where you compute matrix multiply, then you send the data to memory, then you bring it into your vector unit, then you compute something, send it back to memory, blah, 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 boring, boring, boring. It's a lot better to have it connected. So that's what we've introduced today, and I hope you're going to come by our booth or tomorrow at the demo theater to learn more about this technology. Thank you very much.
Thank you, Roger. All right, two to go, fire up. Only a couple more minutes, and then drinks are on the way. So next up, we have Sci-Fi. And I'm here to introduce Drew Barbier. Drew is Senior Director of Product Management. Drew is also a Sci-Fi old-timer and product manager extraordinaire. Drew will talk about Sci-Fi's feature-rich performance family of high-performance cores. Because everybody loves development boards, Drew will also highlight current and exciting new development boards being released over the next year, which are based on these cores, and he has promised me it'll be 3 minutes, so please welcome Drew.
Challenge accepted.
Thank you. You got this.
Thanks, Tiffany. Happy to be here. So for those of you who don't know, Sci-Fi is a RISC-V IP company. We license a wide range of RISC-V processors. Today, I'm here to talk about the Sci-Fi Performance family. These are our 64-bit application processors. And just a few weeks ago, we launched the Sci-Fi Performance PH70. This is our highest end, 6-wide out-of-order processor that we're hard at work building for our lead customers. We also announced the PH70A, which is the automotive variant. But today, I'm not here to talk about those. I'm here to talk about what you can actually buy and use today. And so, by the way, the P550 and the P670 and P470 are all silicon proven. So that's pretty cool. But before we get into that, I want to talk about the full solution, the full story. You know, when we talk about licensing IP cores, we always get into these discussions around PPA, power, performance, and area. And while that's good, and that's what kind of gets you in the door, the discussions very quickly go to the next step. What's the feature set? Because when you're talking about high-performance application processors, it's not enough just to have performance. You have to have the whole story. And at Sci5, we do. So the P670 and P470, we support coherent heterogeneous architectures. The P670 and the P470 implement the same instruction sets. That's RVA22. We also have support for the RISC-V vector extension, as well as the ratified vector crypto extension. We also have support for hypervisors, as well as an I/O MMU product, so that customers can embed I/O MMUs in their SoC. We also have advanced power management features. We also have the new AIA-compliant interrupt controller. So this enables us to support things like message signaled interrupts. We also have WorldGuard, which is our system security solution. And go to boards. So I have a minute left, so I'm racing against the clock here. So everybody loves boards, and I was at Embedded World last year at the RISC-V Pavilion, and about every 5 minutes, somebody would come up to us and they would say, Sci5's cool, RISC-V's cool, but I want new development boards with all these great new features you guys have been talking about. And I just want to say, message received. We've been working very hard with our partners, and there's a number of new development boards that are coming out very soon. So first, I want to talk about what's available today. So the Hi5 Unmatched, we've done another run of these boards, so you'll be able to buy these again from your normal distribution channels like Mouser. I also want to talk about the Star 5 Vision 5.2 board. This is another development board based on the U7 processor. It has graphics and a bunch of cool features as well. Now going forward, the Hi5 Pro P550, I know this one's been a long time coming, and we said it would come around the summer. It's looking like early next year, but it's coming, it's real. It's actually in the pavilion. You can go and see it running Ubuntu. So it's going to be a great platform, and this is based on our Sci5 Performance P550. So this was our first generation out-of-order processor. In addition to that, next year you'll also see the eSwin ESW 2030. This is another P550-based development board that has 4 cores and 8-core solutions. And then towards the second half of next year, I was very lucky to go to the launch for the SoftGo SG2380 a few weeks ago. This is going to be a great product. It has 16 Sci5 Performance P670 cores. It has 8 of our Sci5 Intelligence X280 cores. It has graphics. It has PCI Express. It has everything. And it's going to be put together in a cool platform built by the Milk 5 Oasis guys. So with that, we also, when we launched the P670 and 470 last year, we had some great quotes from both Samsung and Qualcomm. And I know the Samsung folks have gave a number of talks today that maybe gave you a little sneak peek into what they're doing. And we're very excited to hear what Ziad had to say earlier this morning. So with that, I failed the challenge. I am over 3 minutes, so I'm sorry, Tiffany, but thank you very much.
Yeah, you try. I'll take that. You can do that. Close, no cigar. Had I been able to bet on who, like the over-under of who would have made it, I'm embarrassed to say I think one's been under 3 minutes, but things we can work on for next year. We are down to our final one. So I'm here to also introduce as our last one, Tetramem. David George is head of global operations. He is a physicist and engineer who has spent 30 years bringing new technologies to life. He enjoys the adrenaline of activities such as surfing, skydiving, and working for a semiconductor startup, which I'm sure many of you can appreciate. David's going to introduce the Tetramem MX100, the world's first commercial analog memristor compute platform, a revolution in the physics of computing. And with that, David has his 3 minutes. Let's cheer him on. Let's make sure he gets it done.
All right. Just me between all of you and drinks. Okay. Well, thank you all, and thanks to the RISC-V Summit team for this platform. This is great. I joined Tetramem about 2 years ago, in part because I love good stories, and Tetramem is an awesome story. It actually starts about 50 years ago up the road at UC Berkeley, where Professor Leon Chua, who was studying the mathematics of electric circuits, had a hypothesis that a fourth fundamental circuit element should exist alongside the resistor, the capacitor, and the inductor. He called that theoretical device a memristor. Unfortunately, I only have 3 minutes, so I can't tell the whole story. You're going to have to come by our booth for that. I'm going to skip ahead 50 years to today, where we proudly announce the Tetramem MX100, the world's first commercial implementation of the memristor for analog in-memory compute on a RISC-V SoC. The analog devices are organized into neural processing units which compute at rest, letting Ohm's law and Kirchhoff's law use the power of the memristor to calculate instead of requiring thousands of clock cycles of brute force compute. Our memristor was featured in the journal Nature earlier this year in March. We're very proud of that. And with expertise across material science, devices, semiconductor process, circuit architecture, and algorithms and applications, we've now delivered a complete hardware and software solution for neural network inference, for AI at the edge. The Tetramem MX100 uses a RISC-V CPU for control of the SoC and its 10 NPUs, while our analog in-memory architecture provides vastly better throughput and lower latency than purely digital solutions. And flexible across a variety of neural network types, this opens up a world of opportunities for more AI at the edge for low power. And as a marketing person might say, wait, there's more. We did recently announce a partnership with Andes Technology, who you heard from earlier, whose CPU will enable our future products to be even more impressive. And we announced a partnership with Synopsys, whose hospitality we are about to enjoy in the other room to help us get to market faster with those future products. So come to our table, hear the rest of the story I had to skip, learn more about the Tetramem MX100, the leading device in a new generation and a new physics of compute. And thank you very much. Hope to see you in a few minutes. And 15 seconds left.